Hello students, today through this video I am going to give you an introduction to the nano world. What is nano? Nanotechnology is actually understanding, controlling and manufacturing of matter at a dimension of roughly 1 to 100 nanometer. A nanometer is 1 billionth of a meter. The word is derived from the Greek word nanos, which means dwarf or small. Bringing out a comparison between macro, micro and the nano terms, the macro scale is like person, which is roughly equal to 2 billion of a nanometer. An apple is 80 million nanometer. An ant is 5 million of a nanometer. Coming to the micro world, a human diameter it is around 80,000 nanometer. The smallest the eye can see is 10,000 nanometer, and the size of an E. coli bacteria is 2000 nanometer. Coming to the nano, a cellulose microfiber is 3.5 to 100 nanometer, or the size of a DNA is 2 nanometer. The hydrogen atom is 0.1 nanometer. The term nanotechnology was coined by Tanguy in 1974. Richard Smalley is known as father of nanotechnology. This insight for this nanotechnology came from a famous lecture delivered by Sir Richard Feynman, which is entitled as "There is Plenty of Room at the Bottom" at American Physical Society meeting at Caltech on December 29, 1959. This lecture is an inspiration for nanotechnology, in which Sir Feynman described a process by which the ability to manipulate individual atoms or molecules might be developed, using one set of precise tools to build and operate another proportionally smaller set, so on down to the needed scale. So he was actually talking about miniaturization, on which nanotechnology is based. The term nanotechnology means we are designing a system, we are characterizing it, we are producing it, and the application of structures, devices, and systems by controlled manipulation of size and shape at the nanoscale to produce structures and devices and systems with at least one novel or superior characteristic or property. Coming to the properties of nanotechnology, the very important terms that we hear is surface area to volume ratio. Now, we say that surface area to volume ratio increases as we move to the nanoscale. How this is achieved? Can be shown with the help of two cubes. The first one is a single cube with 2 mm in length and 2 mm in breadth. The second figure shows you a series of cubes, means 8 cubes with 1 mm in height and 1 mm in breadth. Comparing the surface area for these two with this formula, this comes out to be 24, whereas in case of this cube, it comes out to be 48. The volume remains the same in both the cases. So surface area to volume ratio comes out to be 3 in case of a large cube, as compared to the small cubes it comes out to be 6. So you can see that the surface area to the volume ratio is increased. But what actually happens with this is, there is a surface area to volume increase in surface area to volume ratio, greater amount of substances can come in contact with the surrounding material, and so this result in better catalytic property, better surface area, since a greater proportion of material can be exposed for the reaction. So as we move to a smaller scale, we have larger surface area, which shows better interaction as compared to the largest cubes. So why nanotechnology? That miniaturization down to the micro nano level, it leads to smaller products which are better suited for mass production. They have lower cost, and completely new functionalities can be obtained at macro level. New functionalities are gained by improved physical and chemical properties like physical physical properties like melting point, and smaller dimensions. We have ability to produce new atomic structures that can handle very small volumes and ratios effects on the natural environment. The unique properties that come with nanotechnology are small dimensions, enabling high speed and high functional density, like lab on chip, lightweight devices and sensors, high sensitivity, larger surface area to volume ratio for improved catalytic effect, higher capacity for adsorption, storage and filtration, diffusion barrier. We have highly effective quantum effects also, which a typical example is quantum dots, like a newly launched Samsung TV, which is actually made up of quantum dots. Which this property I will be discussing later when I will be discussing gold nanoparticles with you. Next is they have better properties, better molecular structures like nanofibers, nanotubes, nanocomposites, and better molecular interaction. The molecular dimension of nanoparticle allows molecular interaction with other molecule like encapsulation, molecular absorption, carriers, and chemical template.